Well, hello everybody, and welcome to the next edition of your lecture. So today we are chatting about Chapter 3, Research Methods and Statistics. So the material that's being presented here is going to expand a little bit on some of the things that have been talked about in the textbook, and as well present a little bit of new information here today. We're going to discuss the steps of the scientific method. So we're going to talk specifically about precision, skepticism, reliance on empirical evidence, the willingness to make risky predictions, and openness in science. And we'll frame our discussion about how these things help the scientific method to come to the conclusions that it comes to. We're going to talk about two very important concepts for research, and that's the concepts of reliability and validity to research outcomes. And then we're going to discuss research methods in psychology, so specifically the four types: descriptive, correlational, survey, and experimental. And then as well, we'll chat a little bit about basic statistical thinking, things like survivorship bias, descriptive statistics, and inferential statistics. So by way of beginning, I'd like to do the land acknowledgement. So as we engage in remote teaching and learning today, I would like to acknowledge that the Saskatoon campus of the University of Saskatchewan is on Treaty 6 territory and the homeland of the Métis. We pay our respect to the First Nations and Métis ancestors of this place, and we reaffirm our relationship with one another. I'd also like to recognize that some may be attending this course from other traditional Indigenous lands. I ask that you take a moment to make your own land acknowledgement to the peoples of those lands. In doing so, we are actively participating in reconciliation as we navigate our time in this course, learning and supporting each other. So, what makes psychological research scientific? Well, there are a few things that help to do that, and we kind of talk about these 5 areas that this is how we understand something to be scientific. And I'll take a moment to talk about each one of these, but the first one we'll talk about is precision. And by precision, we mean that we have a very specific pathway for how to study an idea, and then we not only just have kind of a map of how we're going to come to this conclusion, but we're actually going to take the time to really define along the way in a very precise way to make sure that we're actually measuring the things that we're talking about. So, as we've talked about before, we have kind of these large kind of overarching kind of pathways, right? So the first pathway that we begin with is this idea of a construct. So a construct, again, is something that we can't see in reality, right? So it's this idea of like aggression. We can't really see or touch aggression. I can't just go outside and pick up aggression, put it in my pocket, and bring it home. But we can study this idea of aggression through other types of ways, right? Through peripheral ways. Now, our constructs often lead to theories for how we suppose that things kind of work together or function. These theories then lead to a specific hypothesis of how it functions. And then in order to test the hypothesis, we make these operational definitions. And this finally leads us to evidence. So this is the pathway, I guess, for how we come to the conclusions that we come to. So this is the pathway of precision. So each step along there is necessary to go from a vague, kind of big, conceptual type of thing to a very specific way of measuring something. Well, not only that, we don't just need precision, we also need to have a high degree of skepticism when we're busy doing scientific research. The goal is, we don't want to just accept something because somebody else said that we should do it, but we only want to accept a statement as true or as not true based on the abundance of evidence that is provided. So we want to balance the skepticism out with openness to new ideas because we don't want to be closed-minded and just say, no, there's no possible way that we could have ever found that, right? We don't want to be like, folks in Galileo's time when they said that the universe kind of revolved around the earth, and he said, well, actually, like, everything revolves around the sun. And they were all laughing at him. So we don't want to be like that, but we do want to be skeptical about information, and we really want to weigh it based on the evidence that is there. This leads us then to kind of a next point which really flows well from it, and that's this idea that we only rely on empirical evidence to come to this conclusion. And an idea can only be as useful as the evidence that we find that supports this. Finally, the fourth step here is, at the same time as we were kind of, being a little bit skeptical, maybe a little bit conservative in our estimations, we also do want to make risky predictions. And so when we're talking about risky predictions, it doesn't just mean saying crazy things and hoping for the best, but it's this idea that we want to make predictions that can actually further the scientific evidence on a particular topic. Now, in order to do that, what we really want to do is we want to have a high level of testing whether something can be falsified And when we say that something can be falsified, that means that when we are building a scientific theory or we're testing a scientific theory, we must expose this theory to the possibility of disconfirmation. So when we're testing something, we want to say exactly what will and what won't happen. So for example, if we, find a white swan, we don't just want to say, well, that means there's no more black swans. So instead we want to say, well, we're going to go look and search the world for more black swans, just to test the possibility that maybe there are other colors of swans. We need to have this willingness to make risky predictions, because often one of the things that happens for us as people is this idea of confirmation bias, and that is that we only tend to pay attention to information that confirms our own belief, and we discredit information that disproves it. So we need to have this framework in order to help us to evaluate our theories and our ideas. Finally, we also want to conduct science in an open and a transparent manner. Now, science, for the most part, has been something that for many of us has been done behind closed doors or behind paywalls or in a way that is inaccessible to most people. And so in science, there is a huge push for a greater level of openness, so that we can, that the information is available not only to non-scientists, but also to other scientists. So we want to get out of these silos, and we want to actually share information in order to come to better conclusions. So in order to do this, there are some kind of rules that we have. So one thing is that when we do an experiment, it needs to be described specific enough so that somebody else can replicate or this study to test the conclusions. Not only that, we also are asking now, or many people are asking, to make the data sets be made available so that other researchers can independently look at the data and determine whether or not the authors made statistical errors or came to faulty conclusions based on how they measured their kind of outcome variables. The other part to openness, which is very important, is this idea that all results must be shared so that money and time is not wasted. So one of the major problems in any scientific endeavor is that we tend to really value results that find something, while results that find nothing don't tend to get published, and they tend to just kind of get shoved away. And so it's led to this problem that we call the file drawer problem. And that's that many research studies are not available for review because they've never been published because they found non-significant results. Well, if we're really being scientific and we're really saying that evidence is what we're looking for, then all results, whether you find something or don't find something, are valuable. And so openness as kind of a concept has really called for us as scientists to reevaluate how we share information and what kind of information is available. We don't want this file drawer problem. We need to know everything that's out there so that we don't waste money trying to duplicate something that somebody else has already tried and found that nothing kind of comes. So these are kind of the important values. We're going to move now briefly here and begin to talk about research methods in psychology. But before we even begin to talk about the specific methods, one of the things that we have to do is we have to talk about two very important concepts. And they're the concepts of reliability and validity. In fact, everything else is built upon these two concepts. So let's talk about reliability. Well, according to the American Psychological Association, reliability is the trustworthiness of consistency of a measure. That is, the degree to which a test or other measurement instrument is free of random error, yielding the same results across multiple applications to the same sample. In other words, does this tool provide the same results from one time and place to another? That is the question. So reliability looks exactly at the fact that the thing is consistently measuring in the same way all the time. Well, reliability is great, but not only do we have this giant concept of reliability, we have very specific types of reliability that we look for. So for example, one of the types of reliability is what we call internal consistency. And this is the degree to which elements of a measure are related to each other. Now, when I'm talking about a measure, I'm talking about, like a rating scale or a questionnaire, psychological rating scale or questionnaire. And when we, when we design these things and we test them out on a norming sample, one of the things that we look at is, are the items that are on these things actually correlated with each other? Are they related to each other? And are they kind of the ones that are measuring the same types of things, are they consistently correlated with each other? So we want to make sure that our measures, whatever measure we have, has a high degree of internal consistency. There's also other things like test-retest reliability. And so that's the stability of scores are the same between time A and time B. So for example, a heart rate monitor is something that you really want it to have a high level of test-retest reliability. We don't want a heart rate monitor to be inaccurate. And so we want it to be able to consistently measure heart rate in the same way across different settings so that we know that we're actually getting a correct beats per minute. Otherwise, that would be quite bad. We also look at this idea of inter-rater reliability. And so that is whether or not scores are consistent on a measure across different raters or observers. And so one of the best examples of this would be like a judges panel. So if you ever watch like Olympic figure skating or whatnot, you've got that panel of judges, and so they all kind of give a score for how good it was. Inter-rater reliability is looking at the degree to which different people would rate their scores would be rated similarly. So inter-rater reliability is very important. So oftentimes in psychology, we'll be using this, especially if we're doing like an observational study, and we've trained people for how to observe parents and children playing together. And so we want to make sure that both of the people, or all of the people who are rating this play, would kind of judge the play to look exactly the same, and so that they're scoring the protocol exactly the same. So inter-rater reliability is an important thing that we use a lot in research. And then finally, we talk about alternate forms reliability. So if there are two different versions of a test, we want to make sure that the scores between different versions are the same. So for example, in my work, if I'm giving version A of an academic achievement test, the scores on that should be very similar if that same student happens to take version B at some other point in time. Otherwise, it's not really measuring the same thing. So that's that whole idea of alternate forms reliability, is that if there's different versions, that the scores are kind of meaningful across both versions of the test. So that's reliability for now. Let's quickly switch and talk about validity. Validity is this idea that it's the degree to which empirical evidence and theoretical rationales support the adequacy and appropriateness of conclusions drawn from some form of assessment. All right, that's great. What does that mean? Basically, does the tool measure what it says it's going to measure? All right. Now, in order to determine that, there are different ways that we look to see whether or not this thing is actually measuring the thing it says it's measuring. So one of the things that we look at is something we call content validity. And so that's the extent to which the measure fully and accurately represents all elements of the domain of the construct being assessed. So an example of that would be that if I got a whole bunch of experts together on a topic, let's say the topic is play, a children's play, would all of them agree on the way that I've conceptualized play on a particular kind of rating scale or observational instrument? Okay, so that's that idea of an expert consensus panel. So would all of these experts who really know the content and the breadth of the field, would they agree with how I've kind of come up with this idea? Is this instrument fully capturing the content that would be important to be measured to find this particular outcome? There's also what we call face validity, and that's the extent to which a measure appears to be measuring the construct of interest. So really, does it look like it's measuring what it says it is? So for example, if I'm saying that, oh, I've created a measure of depression, but really if you look at the questions, you're like, wow, these questions are actually not about depression and about low mood. These are questions about stress and kind of work-related pressures. Well, that doesn't really look like it's measuring depression specifically. It looks more like it's measuring workplace stress. So we want to make sure that all of the instruments that we use also have a high degree of face validity so that it actually looks like what it says it's measuring. Not only that, we also want to have high internal validity. So what that means is that's the extent to which a study is free from flaws in its internal structure, and its results can therefore be taken to represent the true nature of the phenomenon. So if we have a high degree of internal validity, really what we can say is that experiment A can prove that A causes B. And prove is in quotations because in psychology as well as in science, we're never really proving anything. We're providing evidence for or evidence against something. And when there is enough evidence that continues to show that we have enough evidence for something, then we begin to say like, well, this looks like this is what's happening. But science is never really about proving anything. Now, internal validity is important. So most studies that are done in a laboratory, they have a high degree of internal validity because they control the environment and they make sure that there are no random kind of influences that can somehow mess things up, okay? Now, the problem with that, though, is that out in the real world, that is a very challenging kind of thing because we can't control for random error in the real world. We can in a lab, but we cannot really in the real world because random error happens. So we also then talk about this thing that we need external validity. And that's the extent to which the findings that we found in one context, so for example in a lab, that can generalize to other settings and contexts. So we want to make sure that the results from one study can actually be applied to other persons or groups that fit the sample characteristics. So here's one of the big areas in psychology where we spend a lot of time and energy trying to find, to make sure that the things that we've done in a highly controlled setting, a setting that has a high degree of internal validity, that those things generalize to the real world. That is a very important kind of thing. And so that's kind of the internal versus external validity kind of trade-off. Now, it's important for you to remember this, all right? You can have reliability without validity, but you cannot have validity without reliability. And what do I mean by that? Well, I mean this. You can have an instrument that is consistently coming up with the same numbers each time, but it is possible that that instrument is not actually measuring what you say it's measuring. Right? So just because it's consistently measuring in the same way all the time doesn't mean that it's actually measuring the thing that we want it to measure. So that's why it's possible that you can have reliability without validity. But if your instrument is truly valid, then it must also be reliable. So you cannot have validity without reliability. I'm going to pause here and we'll pick things up in the next section. So thanks for coming.